Hey guys, welcome back to another new video. Here we go with the previous year questions of Unit 2 Eigenvalues and Eigenvectors. Let's see first question. Let A is a matrix of 1 0 0 1 0 1 0 1 0 and A inverse is equals to alpha A square plus beta A plus lambda I and alpha beta gamma R belongs to R. Then find alpha plus beta plus gamma. So here to find the A inverse, you need to use the Cayley-Hamilton theorem, and for that first find the characteristic equation of A, find S1, S2 and S3 and get the characteristic equation, and in that characteristic equation substitute A in the place of lambda, you get another equation, and for that you no need to do the verification for Cayley-Hamilton theorem, just you need to find the A inverse, then multiply that equation with A inverse and equal to 0. When we multiply with A inverse, A cube becomes A square and A square becomes A becomes I and I becomes A inverse. From that, A inverse is equals to some equation you get. From that, take the A inverse outside and substitute the matrix of A square, A and I. So here to get the A square, A and I, find the A square, that multiply A 2 times, then you get the A square, substitute those matrices and you will get the A inverse. So after getting the A inverse, that from that equation you need to get the coefficient of A square and coefficient of A and coefficient of I, and do sum of all those constants and find the A plus alpha plus beta plus gamma. That gives the final answer. Then next we have find the nature of the quadratic form 10x square plus 2y square plus 5z square minus 4x5 minus 10xz plus 6yz. So here to get the nature of the quadratic form, convert this quadratic form to the canonical form or normal form. So for that, first write the matrix from this given quadratic form and get the characteristic equation, that is the determinant of A minus lambda equals to 0. Then from that get the characteristic equation, it will in the form of lambda. You will get a cubic equation, as there are 3 variables here x, y and z. Then find the eigenvectors for each So by solving that characteristic equation, you will get the eigenvalues and substitute, take lambda as a eigenvalue and substitute in the characteristic equation, you will get the eigenvector for each eigenvalue. Then after check whether they are pairwise orthogonal or not. That is nothing but x1 x2 transpose must be equals to 0 and x2 x3 transpose should be equal to 0 and x3 x1 transpose should be equal to 0. So from that we gives the pairwise orthogonal or not. So check whether they are pairwise orthogonal or not. If not, make them as pairwise orthogonal by taking another new vector as ABC. Then after find the normalized eigenvectors. So to get the normalized eigenvector for each eigenvalue, take norm x1. For example, if the eigenvector is x1, take the norm x1, that gives is nothing but under the root of first element square plus second element square plus third element square. Then that gives the norm x1. Then x1 by norm x1 gives the normalized eigenvector for x1. So similarly find for x2 and x3. So you will get all the normalized eigenvectors for each eigenvalue. Then after you need to find the normalized model matrix P. So to get the normalized model matrix P, take those eigenvectors in the form of matrix. You will get in a 3 by 3 matrix and do the transpose of that model matrix, that gives P transpose, and then after multiply those matrices as in the form of P transpose A into P, and that must be equal to the D, where D is a diagonal matrix. It is of the diagonal matrix with eigenvalues. Then P transpose A into P gives the diagonal matrix. Then you need to get the canonical form, that is Y transpose D into y, where y is the matrix of variables y1, y2 and y3. So when you do y transpose d into y, you will get one equation in form of x y1 square and y2 square y3 square. So that is a canonical form of the quadratic form of the given quadratic form. So after getting the after converting the quadratic form to canonical form, find the nature of that quadratic form. So to find the nature of the quadratic form, we have positive definite, semi definite. So from that you need to check and write the nature of the quadratic form. Next question we have, let A be a 3 by 3 matrix over R such that determinant of A is 6 and trace of A is 0. If determinant of A plus I is equals to 0, where I is the identity matrix of order 3, then find the eigenvalues of A. So the given here, it is a 3 by 3 matrix and trace of A is 0, nothing but sum of the diagonal elements is 0. And here determinant of A means product of the eigenvalues is 6. So from that we can get the eigenvalue and use this condition. They gave determinant of A plus I is 0. And next question we have, reduce the quadratic form to canonical form. Same as the second question, just reduce the quadratic form into canonical form. No need to find the nature of the quadratic form. Then we have diagonalization of the matrix A, that is A of 1 0 1 and 1 2 1 and 2 2 3. So in this matrix you need to diagonalize the matrix. For that you need to find the model matrix first. So first take the characteristic equation, get the eigenvalues and substitute those eigenvalues in characteristic matrix equation and you will get the eigenvectors. So after getting the eigenvectors, take the model matrix P, where it consists of eigenvectors of first eigenvalue and second eigenvalue and third eigenvalue respectively. So after getting the model matrix, you need to find out the adjoint of P. You need to find the P inverse. So to find P inverse, you have to use a formula as P inverse is equals to adjoint P by determinant of P. And to find adjoint of P, there is one method. That method I have explained in my previous videos. Check those videos. So P inverse, after finding the P inverse and that matrix which transforms the matrix A into the diagonal matrix such that it satisfies one condition as P inverse A into P is equals to diagonal matrix D. So where D is a diagonal matrix that consists of eigenvalues. So that is what diagonalizing the matrix. So P inverse A into P gives the diagonal matrix. And next question we have here, find the rank, index, signature of the quadratic form. So they given a quadratic form here, convert the quadratic form into canonical form. So from that write the rank, index and signature. I have explained one problem in my previous video, check those videos. Find the nature of the quadratic form. So just similar as this, convert this quadratic form into canonical form and then find the nature of that quadratic form. The next question we have here, determine the eigenvalues and eigenvectors for this matrix B, where A matrix is given as. So as this is a 2 by 2 matrix, we get the characteristic equation in the form of quadratic equation. So when you solve the quadratic equation, you will get two eigenvalues. So those two eigenvalues substitute in matrix B in this equation. First you substitute first eigenvalue in B and second eigenvalue also you substitute in the B. Then you will get the eigenvalues for B matrix. Then after by using those eigenvalues, find the eigenvectors. Find the nature of the quadratic form. So similarly as this quadratic form, convert into normal form or canonical form and find the nature of that quadratic form. Next here we have verify Cayley-Hamilton theorem for A is equals to matrix and hence find A inverse and find the eigenvalues of B, where B is given as a power 5 minus 4a power 4 minus 7 into a power 5 plus 11a square minus 7 minus 10i. So just you need to verify the Cayley-Hamilton theorem. So after getting the characteristic equation, you need to substitute the lambda in, you need to substitute the a in place of lambda. Then from that just here we have 2 by 2 matrix. Then you will get a in form of quadratic equation. Then after that find a, already the given, so substitute in that equation and verify it. Then after find the a inverse. So to find a inverse, multiply that equation with a inverse. Then a cube becomes a square becomes a, and a becomes I, and I becomes a inverse. So from that solve that equation and take a inverse as one side and remaining elements on the other side. Then substitute all those matrices and finally you will get the a inverse. That is what a inverse. Then find the eigenvalues of b. So when you substitute these eigenvalues of a into this, you will get the eigenvalue for b. So for example, if we say that a got 1 and 2 as eigenvalues, then substitute 1 in this equation as 1 power 5 minus 4 into 1 minus 7 into 5. So substitute like that, you will get the value, one value here. That value is the eigenvalue of b. Now next take another eigenvalue of a, that is 2, and similarly substitute in b and you will get another eigenvalue for b. So in such a way we solve this problem. So verification, finding a inverse and finding the eigenvalues of b matrix. And next question we have here, find the eigenvalues and eigenvectors of this matrix. So it's very easy to solve it. Just characteristic equation, solve that by using calci, you will get the eigenvalues. Now take each eigenvalue, substitute in that characteristic matrix equation and you will get the eigenvectors for each eigenvalue. Next also we have the same question, find eigenvalues and eigenvectors. Same third question, find eigenvalues and eigenvectors. Now next, show that the eigenvalues of a Hermitian matrix are real and distinct. So Hermitian matrix we know. Just take one example. For example, if we say it is a 2 by 2 matrix, first element is 1 and second element in that same row is 4 plus 3i, and next element is 4 minus 3i, and next element is 5. So here diagonal elements are 1 and 5. So it is a 2 by 2 matrix. So in the 2 by 2 matrix, Hermitian matrix nothing but that matrix A is equals to A conjugate of that A transpose. So when we have the A matrix, so transpose of that matrix gives another matrix, and when we do conjugate to it, that becomes A. So A is equals to A transpose conjugate. So that gives a Hermitian matrix. So we have to show that the eigenvalues of Hermitian matrix are real and distinct. So we have to prove this. So we will get always the eigenvalues as real and distinct. So by using any example problem, solve it and prove that the eigenvalues of a square Hermitian matrix is always real and distinct. Next, state the Cayley-Hamilton theorem. Verify the Cayley-Hamilton theorem for the matrix 1 0 minus 1 1 2 1 2 2 3. So state Cayley-Hamilton theorem. So write about the Cayley-Hamilton theorem and then after find the characteristic equation, just similarly as I explained in my previous videos. Check those. Just verification is needed, no need of finding A inverse, just verify it.